So again, the community fault model is one of the longest standing and widely used resources that has been developed by the Southern California Earthquake Center. It's used in probabilistic seismic hazard analysis, in fault system studies, even in education and outreach activities. The most important part about the CFM is really the C that's in front of the name, and that reflects that it stands for community. And that means really two things in this context. The first is that there are many, many people who have contributed their understanding, their insights into the geometry and characteristics of particular faults that are represented in the model. And many of you are of course, here today, and we'll try to continue to acknowledge your contributions to that throughout this process. The second part of community, though, is that we are gathered together to actually evaluate a series of alternative representations of faults that are included within the model. From the very beginning of the CFM, we recognized that there were going to be particular faults for which we didn't know the geometry at depth. And there have been different authors, different studies that have argued for differences or distinctions in fault representations in terms of the dip of the fault, the degree of segmentation of the fault, or something similar. So this process is basically gathering together a series of both contributors to the CFM, experts, people who simply have good judgment about the nature of fault systems to help us to evaluate those alternative fault representations. And the outcome will be that those that are ranked the highest by this group will be defined as preferred representations in the next version of the community fault model, which is issued, which will be version 6.0. I do want to emphasize, however, that the alternatives will remain part of the model. They'll remain accessible essentially to the user community to ensure that we can continue to assess them, to study alternative representations, and hopefully through future studies, future insights, new data collection, we can gain further information to help refine our understanding of the fault systems in Southern California. Next slide. So, fortunately, we're not asking you to review the 400 or so faults that are present in the community fault model. Rather, we focused our attention to 6 regions and a series of faults within those regions where, let's say, the differences between the alternative representations are substantive. They're not just slight refinements, but rather they're differences, again, in the dip of the fault, in some cases, even the dip direction of the fault, to first order the degree of segmentation. And so these different alternatives are going to be meaningful in the context of the use of the community fault model, let's say in the context of probabilistic seismic hazard assessment. So we've identified the 25 or so faults that we think it's important for you to provide perspective and guidance on in terms of evaluating these alternatives. Next slide. As Scott mentioned, we have some very capable tools to help us with this process. I'll reflect back the first evaluation that we did like this, and I know some of you attending the call today were actually at that first evaluation in 2003. As I recall, it was held at Scripps, and we spent a couple of full days essentially going through the hundreds of faults at the time that were being considered for inclusion in the model. Again, today we're going to focus our attention, over the next several weeks, focus our attention on 25 or so faults. And to do this, we're obviously doing this remotely or virtually, and we've got 2 very capable tools that are going to help us with that process. The first is a survey tool that you're going to be essentially working through that's going to be framing the questions for you. Which fault representation do you think is better constrained, is more accurate for characterizing a particular structure or source in Southern California? You'll also have an opportunity, in addition to ranking those alternatives, to actually provide comments and guidance to us that we can use in figuring out how to improve the community fault model going forward. Because of a lot of hard work over the last couple of years, we also have a very sophisticated and capable viewing tool for the CFM that's going to give you the opportunity to view the faults in map view relative to earthquakes, as shown here, but also provide 3D perspectives on the fault geometries, including the alternatives that hopefully can help with your evaluation. Next slide. I do want to again go back to the point that this is a community activity, and there have been a large number of people who've contributed to the community fault model in terms of their expertise in particular faults. In addition to that, there are some people who have really been developers of the CFM that have made major contributions, and several of them are participating today. Craig Nicholson, I know Chris Sorling has contributed a lot in terms of numbers of faults to the community fault model. Eyal Halkson, as a seismologist, was working with us from the very beginning. And we could literally put 20 or 30 other people in this list as having contributed in a meaningful way to the CFM. So we really appreciate the participation of those who are here today and all the others over the years who've made these important contributions. And also, these tools that we're going to be working with have really been enabled by a lot of hard and professional and dedicated work by people in the SCEC IT and software team. Of course, that includes Phil and Tron, Edric, who's participating today, and particularly May in the context of developing the CFM viewer. I'd also mention that Anna Luisa a Harvard undergraduate, has helped us actually developing the survey tool, and she's joining us to participate today and will also be online to help us throughout if you have questions about the survey tool. So next slide. So the roadmap in the next hour and a half or so is very clear. We've already covered the first topic, which is just the welcome and overview. I'm going to turn it over in a minute to Scott to give us a very brief history of how the CFM was developed. Then we're going to have a walkthrough of the surveying tool, the evaluation tool that you'll be using. We'll have a time for questions after that. Following that, we'll have a discussion or walkthrough of the CFM web viewing tools for seeing the fault geometries, particularly in 3D interactively, and have a question discussion session after that. I'll come back at the end and simply try to highlight what your tasks are and the deadline associated with those. And then we'll have some time at the end for wrap up and discussion. Okay, so with no further delay, I'll turn it over now to Scott.
Great, thanks, John. So I thought the appropriate place to start would just be to remind people what CFM is. And John sort of touched on that at the beginning, but it's this hierarchically organized set of three-dimensional fault representations. So essentially the CFM is a geometry. It's a collection of geometries. The current version is 5.3.2. We have 442 individually named fault representations, but we also provide alternatives. They're not served by the web viewer because what we recognized was that many of these alternatives aren't really different interpretations. They're essentially just updates or improvements in the data from previous representations. So what we've done in the past year or so is we've gone through, and like John said, we've identified faults where significant differences exist, and those are what your evaluation is going to be focused on. Basically, surfaces in the CFM are based on any data that we can get our hands on to constrain these faults in 3 dimensions. So here you see a map view of the traces of CFM. These are available on the CFM homepage. We also have simplified maps and several in-betweeners. If you like fancy or medium fancy, we've got you covered. You can also download the trace data if you just want the traces. Just keep in mind that CFM is a fully 3-dimensional model. So a brief history of the CFM goes something like this. The CFM has been in development since the mid to late 1990s, but the first official release was around 2003. With about 133 faults. And Andreas had to dig deep through the archive to get this image, but he shared it with me and it's great. It shows how far we've come. 133 faults, now we have 442. But not all new versions represent additional faults. For example, from CFM 3 to 4 and 4 to 5, there was a great effort put in to put more detail in the surface traces of these by Craig Nicholson and others. And so it's not just a matter of how many faults we have, it's how detailed the representations are and how well they're represented. So this is what we hope to identify is what should go into CFM 6, as what John alluded to earlier. And before we get too far into this, I think it's always worth reminding people that CFM, there are various fault models out there. USURF3 is a commonly used model. CFM is commonly used, and the USGS faults or quaternary fault database is another common model. Now, all of these are good in their own right, but they're distinct products. And it's really, we need to be crystal clear of what we're evaluating here. The USURF model was basically a seismic hazard model. It has 3-dimensional fault surfaces, but they tend to be geometrically smooth. The CFM is more complicated than USURF, geometrically speaking, and it has more faults. And it was derived for various SCEC activities. And the USGSQ faults is just a two-dimensional fault trace model. There's no third dimension. Maybe there's a dip on some segments, but there's certainly no three-dimensional representation. But the Q faults are extremely detailed. Now, all of these models sort of inform each other and are based on each other, but for our purposes here, we're talking about CFM 5.3. John mentioned that we have web tools. So one detail that you need to know and why we're having this workshop is that the web tools that are publicly linked on the CFM homepage up here, we have cloned that and made a separate web interface designed specifically for this evaluation period, because the alternatives that you'll see in the survey are not in the public CFM release. Some of them are either new or we just don't serve them because there are too many. So this is the URL to the temporary evaluation tools. They're exactly the same as the regular CFM tools, except they also have the alternatives. So in a later session, I will give you a tutorial on how to use the web-based tools. So feel free to use the normal viewer, just know that there's no alternatives in there. Our web-based interface has the ability to load seismicity in 2 dimensions. Be patient. It's 1.6 million events. Takes 35, 40 seconds. Here they are shaded by color, where color represents depth. We have the Hoxton et al. Catalog and the Ross et al. Catalogs available. Hoxton showing more time but less events, and Ross showing more events but less time. So they're both useful. You can change the background image. Here I'm using an aerial photography, the Esri imagery. And let's sort of zoom in on an area to continue this conversation. Oh, this is the same thing, but with the regular background image. So the next question becomes, how do we construct a model like the community fault model? It's actually quite a daunting task. Building and maintaining this is quite the challenge. And there are a whole bunch of challenges that I've listed down here, but what I want you to focus on is this one. And this is why we're here today. The fault source is actually quite diverse. There's a whole bunch of different styles and kinds of data that can be used to constrain a fault source. And thus, we need a wide range of reviewers with a wide range of expertise. Many of you were emailing me saying, I can't evaluate the CFM, I don't know every fault. We don't expect anybody to know every fault, but everybody was invited or has been accepted here because you have an expertise that will be valuable for us. The other challenge is there is a constant influx of new data and papers, and it is daunting to keep up with it, but we do our best. So at the end of the survey, you'll get the option to let us know if there's new stuff that we haven't included in our model. So again, change the background image. Let's zoom in up here to this little red box to the Ridgecrest area to continue this conversation. So this is, again, the web viewer. The web viewer also shows significant seismicity from 1900 to present of greater than magnitude 6. And so what you can see is the Ridgecrest 6.4 event and the 7.1 event. And your first thought is, well, why don't you just construct a CFM? Maybe this is your thought. Why don't you just use seismicity? Well, you can see here, there's a lot of seismicity on the Ridgecrest fault structure because it had a large coseismic event too, actually. Well, you can create a model based on seismicity in some regions, and that is what the Ridgecrest representation in CFM is based on. And I'll show you an example of that later, but look at Garlock down here, for example. I'm gonna make it fat. There we go. The seismicity on the Garlock fault is very diffuse, and there simply isn't enough seismicity to constrain a surface in 3 dimensions. And this is true of most of the faults in the CFM. So how do we build the model then? Well, I'm going to give an example that I know pretty well, which is the Ventura-Pettus Point fault from Judith Hubbard and others paper in 2014. So again, the web viewer, we're in the Western transverse ranges over here. Let's zoom in. This is the South San Cayetano fault and then the Ventura fault. And what Hubbard et al. Looked at was basically all different kinds of data that they could use to create a 3-dimensional model of this fault surface. For example, this is a figure from the paper. They have 3-dimensional seismic reflection profiles from industry. Those have to be interpreted. They have surface traces based on geologic mapping and the fold scarp. They have industry wells with dip meters and resistivity logs. And they take all of this information, put it into a 3-dimensional computer-aided drafting program, in this case, GoCAD, and fit a surface to it. There are pros and cons to this. The main cons are that this is a manual hand-built surface that is not possible to automate because all of these independent data sets have to be interpreted. So this is very time intensive. It's not uncommon for a graduate student to spend most of their thesis interpreting just a few faults, maybe. And thus, error estimates are not practical or really even possible because there's errors in the interpretation that are unquantifiable. But I would argue the pro is that using the most different kinds of data that exists to make a fault model is probably the best way to go, but we don't get error estimates. So keep that in mind. Now, like I said, there are some that we have a semi-automated method for creating fault surfaces. Mainly, these are events that have large amounts of seismicity, like the Ridgecrest sequence. So Riesner et al. Laid out an objective method where you can take all the hypocenter data, all of the focal mechanisms, and the surface rupture and surface trace data, and put those all in a quantitative algorithm and create a 3D surface that's objectively defined. And so this is nice because we can get error estimates and it's reproducible. But again, currently this has only been used for the Ridgecrest sequence. Sarah Carena and others did something kind of similar for the Northridge fault many years ago, but this is not how most of the CFM is built, although we've targeted some future locations for this method. Then there are faults where the single fault surface, speaking of Sarah Carena and others, who is here, thank you. Thanks for joining us. The Northridge thrust, or also known as the Frew thrust, is based on two different studies that are completely independent of each other. So this is a three-dimensional picture of the Northridge thrust rendered in MATLAB. That's the hypocenter from the 1994 event way down there. And this sort of heart-shaped outline is basically the region that Carena and Suppi looked at in their paper where they relocated seismicity and did some modeling to figure out what the surface is. And it has beautiful corrugations in it and non-planar geometry. Ken Hudnut and others wrote a paper in '96 that showed that to fit the GPS, you need a fault. They used planes, but their planar fault patch was actually quite a bit bigger. So what does CFM have? Well, CFM merged those two studies where we have the detailed data from Carena et al. That you can see the detailed geometry. The Hudnut study, we sort of merged them. So the fault gets very flat and simple out here and is very detailed where there's data. So the mesh can help show that. So we try to use all the data that we can to constrain these fault surfaces. So where we're going to go next is we're going to turn things over to Andreas Plush, who's going to take you through this survey tool and let you know exactly how it works and what are some of the questions that you might have. And we'll have a chance for everybody to ask questions after that session is over. So I think what I will do now is I will turn the screen over to Andreas.
Thanks, Scott. Yeah, let's look at that survey tool. Let me share my screen because we're going to look at that live. My Zoom just froze for a second, but it's back. Okay, so share. All right, so thank you for joining us today and agreeing to participate in this effort using these tools and learning about those today. As John mentioned, some of you have participated in past evaluation efforts and will recognize that this evaluation is quite different and hopefully more streamlined and efficient. And it is centered around this web-based survey tool, which will guide you through the evaluation. So what will happen is that later today, you will receive email with a personalized, unique link just for you to get to your evaluation survey like this. So the link will look something like this, Harvard, Qualtrics.com, and then an ID. And so please check your spam folders. It might end up there because it might be a little bit unusual. So that's one thing to keep in mind. So we'll want to send these out later today. And just be aware that this link is just for you. So please do not share it, because if you share it, there's a chance that your responses will be modified by whoever else is going to use the same link. So you don't want to do that. So it's just for you. The responses going through the survey will be automatically recorded. And this will mean that you don't have to go through the whole survey in one setting. You can interrupt at any time and then just use the same link to go back to wherever you had interrupted your process. So yeah, it should make it much more manageable to go through as many faults as you can. All right, so let's do that now. So let's go through a complete evaluation of just a fault. So when you click on that link, you will get to this page, and it's just first introduction to the evaluation process and to the survey. It has a first explanation of the ranking you will do for each fault. And the way to get through the survey is by getting to the bottom of each page and then clicking on that arrow button to get to the next page. So the next page gives you more explanations, in particular of how you want to choose your ranking. So there's values between 1 and 5 to choose from. 1 meaning that the fault is very well constrained and matches what you think the fault, according to your knowledge and expertise, should how that fault should be represented. 5 is a very poorly constrained fault, which we don't know much about, and model-based, no direct constraints, or the way it's represented maybe is not quite consistent with what the constraints and data you're aware of. So this 1 is the best rating, and 5 is the worst rating. And so you can, when we do that in a second for a fault, and we'll also go through for each fault the description or introduction to more information about each fault using these buttons. But this page is a table of contents page, which just summarizes all the faults which we included for this evaluation, which have these major alternatives, which John had listed initially. And you will be able to get back to this table of contents page from anywhere. So you can always come back here. So let's just now continue. Let's see if I wanted to say. All right, so one thing to keep in mind is that this is a selection based on significant alternatives. But of course, the model has more than 400 faults, and you might want to look at other faults in the model, and you'll have the opportunity to do that using the same tools. And at the end of the survey, there will be an option to actually provide additional information or feedback on additional faults or other faults you want to comment on. All right, so let's look at a fault. So this is just the first one, and notice that there is this hard to notice menu button here on the side, which again gives you direct access to any fault directly without having to navigate through other faults. So this is the first one. And so what you'll see is for each fault, overview perspective like this. So this is the Southern Death Valley fault and Panamint Valley fault. What we have done is to show in blue the representation which is currently available as the preferred or current representation of the fault in the model, and then in yellow an additional optional alternative model. So here's a clear difference. So one is vertical, the other one is a low angle dipping fault representation. And then if you scroll down, you will see these two different alternative representations, separate from each other. Here's the blue currently preferred version of the fault, and you've side in yellow the alternative representation of the fault. All right, so that gives you a first sense of what you're looking at and what you should think about. And I'll start to this already now here. And these drop down buttons here then let you actually provide a ranking. So if you think that this preferred current blue representation is let's say moderately constrained, so 2, or maybe let's make it a 3, and the same for the Panamint Valley fault. You would pick that ranking, and then to actually have an impact on the selection of model for CFM6 of sort of consensus model for CFM6, you will need to also provide a ranking for the alternative. So, and you can pick any number, but if you pick the same ranking number, it won't have any effect. So you want to make sure, or just to have any impact, we would want to have a different ranking for the alternative, something like that. Okay, and so how do you decide what kind of ranking you want to provide? And ideally, you already have knowledge and have studied or were involved with some of the faults, and so have some some expertise. And this might be reflected here in this description. And otherwise, first thing to do is to maybe look at that textual description, which is intended to be really descriptive and just list the main characteristics for each fault representation and what kind of source data went into constructing each representation. So you can look at that. Typically, there is a Q-fault reference, which will provide details on the geologic mapping and sort of surface features and dips of the fault. And then any kind of other references and source data, usually dealing more with deeper structure. So you can look at that, and then if you want to really get into studying a fault, can look up any of these references and others. Let's not do that now, but that's the process, the first process. And if you then want to sort of get a better idea of, in addition to that perspective view, what actually is included in the CFM, you will want to go to the web view of the CFM, which Scott had started to outline, and we'll link directly to the viewer and to the 3D option in the viewer, and provide you with a window, a new tab like this. And Scott will go through how to use that in more detail. So we go to the 3D view, the hypercenters catalog, two different ones, but then you can also go back to the just map with different backgrounds. So this will be very, very helpful to give you a better sense of the actual sort of 3D geometry, what is actually in the CFM. Okay, so let's go back here. And finally, there's a quick video showing sort of spin around view of the faults like this. Let's see if we can make this bigger. Well, I'll leave it. But that's sort of an easy option in addition to the web viewer. If you want to get a sort of quick sense of these blue and yellow alternatives, you can just look at the video and with a 360 view of the full faults like this. And that's available for all of the faults. So close that, go back here. All right, so okay, and then there's also the option to not rank a fault. Can just leave it, or if you're comfortable with providing a ranking, you can go back to like no data, no value rankings. But of course, we hope for most feedback for as much as possible. And typically, often, if you're familiar with the fault, you will want to provide or can provide additional comments. Let's see, in this case, I don't know, aware of other work on the fault, or suggest a hybrid, let's say a hybrid model, which combines somehow these two alternatives together. And ideally, you will want to provide source data, source references for that. See, whatever, Smith. Something like that. All right, so okay, and then that's it. So once you click here on that arrow button, this will be recorded or will be stored, will be saved. And an indication of that is that now you get a check mark next to your fault which you have evaluated, so you can track progress throughout the evaluation. All right, so and that's really all there is to it. So we want to work through probably in some order, probably the faults you're most interested in first, but then hopefully some more. This list of faults. And then finally, you get to the review and submit portion of the survey where you finish up. So you click on that. And there's a note that, please make sure you really want to submit it and review your answers. So you click review. And then there's another clarification that once you actually proceed from that page, there will be no way actually to change anything and or add anything. So only if you're ready, please proceed from that page to the actual final submission. If you still accidentally press the right arrow and submit and want to change something later or add something later, you can always contact us, and then we can just generate a new link, a new survey link to to redo the evaluation. But the idea is that after you went through the process, you then finally submit with that last step. Yeah, and then we'll make actually this is actually a little larger. We'll make this probably a little larger, but as Scott also mentioned, this is then the place where you can have any kind of additional feedback, including on faults you are missing, I think are important to add to the CFM. For example, there is please consider the state line fault, which is very far to the east.
Great. So as Andreas is finishing up, we're going to be opening up the floor for questions.
And then you submit. All right, so that's it. Yeah.
Okay, so that was a sort of a walkthrough of what the survey tool actually looks like. Does anybody have any questions that they would like to either type in the chat or just unmute yourself and ask? There's only 29 people here, so if you don't want to raise your hand, you can just unmute and ask.
Scott, Andreas, real quick. I understand that for these faults and their alternatives, you have brief descriptions on why certain faults, I presume, were selected as the preferred fault and others were considered alternatives. Andreas probably said it, but I missed it. How do you access those descriptions? Like when we were just at the Panamint Valley fault, how do you access that page? Where's the button for that?
So each fault that is going to be evaluated has its own page, and Andreas is scrolling through it right now. Right under, yeah, you got to go next, Andreas, and next again. This is still the instructions to the survey.
Okay.
There are
It's the
giant
description
colored
button.
buttons and the button that says description. And
Okay, got it.
we spent considerable effort trying to make these informative, but not judgmental in any way. We simply describe this is what the data is that constrains them.
Right.
So yeah, but those are the buttons that basically have the information that you need.
Yeah. Thanks.
Austin, do you have a question too?
Yeah, I think you sort of just answered this basically, but it was again around how exactly what the rubric that we're using, the sort of ranking 1 through 5, really means. To some degree, the way the different rankings are expressed is based on how well constrained the fault is, but to some degree that information should already be registered in terms of what the fault is based on, right? Is there, I guess we can click through the description panels for each of those faults. Are they already ranked in some way or defined by variations in how well constrained they are by existing data? And is our role to evaluate that input data or to sort of add additional information for particularly unconstrained faults? Could you?
So John or Andreas can jump in if you want, but my basic, I guess the best response I can give is it's not so much a matter of this fault has more data than that one, so it's better. because they might come from completely disparate data sets where one data point in one is more valuable than 1,000 data points in another. And that's why this kind of community evaluation is so important, because if this were simply a grand inversion of a single data set, we could simply do statistics and say which one is best. But because I mean, how do you rate a seismic reflection interpretation versus relocated hypocenters? You know, it can be quite difficult to make decisions on that.
Okay, yeah, thanks. I appreciate that perspective.
Okay, and I'll show you later in the evaluation. In the next session, we're going to go through the web-based tools. And one of the nice things that you can see in the actual mesh is where the data is dense, the mesh is dense. And so if you use the web-based tool that is linked there, the web viewer, I'll show you how to see that in the next session. But yeah, that's a great question. I'm glad you asked it. So we tried to keep the rubric very simple. It's obviously an opinion, because if it was a quantitative parameter, we wouldn't need a group. So Athanasios, did I say your name right? I probably didn't. You can unmute.
Yes, that's fine. Yeah, the name is correct as you pronounced it. Thanks.
Woohoo.
The previous question actually helped me a lot to understand the purpose of this evaluation, because I'm used to rank faults with respect to their quantitative information. So I hear my voice back. Is there some?
It just means your microphone's probably close to your speakers.
All right. Okay. So what as I wrote in the chat, the ranking is based on some constraints, but the constraints are based on the data source. Really, they're not based on how accurate is the information. For example, the accuracy of the aftershock relocation. What's the errors there? Are there large errors or small errors? What is the error in the reflection profiles in terms of the position of the fault? So if you don't, so this information is not really necessary now. So if I understand well, okay.
No, the job of the evaluators is to look at the references and to determine and the descriptions, and to determine based on your own professional expert opinion which one of the evaluations is best constrained by the data. Or is most geologically or geophysically reasonable. Because again, the data is from disparate sources of disparate quality, and it's apples to oranges comparison. So it's difficult to make this simple. And that's essentially why all of you are here and we need you. Did that answer your question, kind of?
Yeah, I think in a large part, yeah, but there's another aspect of the evaluation is who is going to use that.
Who's going to use the evaluation?
No, not the evaluation, I mean the data set, because well, I know about the California fault model, but I'm not sure who is using. Is for example, if an engineer would like to construct a tunnel, they would like to start building the tunnel after the fault trace, not like crossing the fault. So the fault trace is very crucial. So if they use this model, they need to know if this model is accurate enough, or they have to use another model.
Right.
I don't know what if you understand what I mean. Who is if the people who are going to use this are people who educate students or university students about faults and fault surfaces, probably is okay.
Yeah.
If the people who are going to use this information are professional people that would like to estimate hazards or risks to their work, then probably they need more information.
So we have a disclaimer about that in the web viewer, and I'll show you that later, but it sounds like John has some comments.
Yeah, I'll be happy to step in here just to really emphasize what's most important for this process. The most important outcome of this evaluation is the relative ranking that you provide between two alternative representations of a fault. because collectively, the representation of the fault that we deem to have the most credibility, it has the most or the most robust data, or as Scott mentioned, is the most geologically or geophysically reasonable. That representation of the fault will be included in our preferred set of faults that comprise the community fault model version 6.0. And so users who would go and be interested in the preferred representation of the faults will essentially find and access that fault model. Having said that, a sophisticated user that's doing something like probabilistic seismic hazard analysis or probabilistic fault displacement hazard analysis would actually presumably be looking at the full range of alternative representations in the model. And they would develop some kind of a weighting scheme to consider the likelihood that each of those representations was accurate or appropriate. So again, there are really two tiers here. And I think our first goal is to really help have this community essentially weigh in on the relative rankings of the faults. And as a secondary sort of ask, we're trying to get a sense of what you think the quality of individual fault rankings are. I don't know if I hope that helps a bit.
I think so. Ray, you have your hand up.
Yes. First of all, thank you very much. Can you hear me okay?
Yep, you're good.
Great. I have two questions that are sort of similar to these a bit. First of all, are there rules for the data input? Because, for example, in the steering committee for the National Seismic Hazard Map and the update we're working on as well, there are quite specific rules about what data goes in. It has to be essentially in a peer-reviewed published paper, whereas there's lots of other data. Just to throw out an example, PG&E's done a lot of work on the Hat Creek fault that's in reports. We did a review for songs that wasn't used as well. And I'm wondering what your rules are, where they're posted, and whether you want us to tell you that there's something that has been done, by some sort of a geotechnical company or some other organization that isn't included here. Would you include that? Mm-hmm. And then somewhat related, we keep coming into this issue of what to do about things that are in there that are just wrong. Mm-hmm. It's one thing to say, I prefer this, or this is a little bit better or worse, but do you have an approach or rules for things that we're pretty sure are wrong? Would we make a comment and say, this has been disproven by this other piece of work or whatever, and so I don't think it should be an alternative at all? And that question's kind of more curiosity. Do you just keep adding alternatives, or at some point do you take some alternatives out?
Yeah. Both good questions. I'm happy to jump in and start, Scott. I think the second question is straightforward. Yes, rank it a 5 and tell us it's wrong and tell us why it's wrong. And obviously that will both provide a way that we can understand that that is let's say a poorly defined fault surface. It also gives us guidance as to how we can improve the other fault representations that may be in place or we may need to develop. We don't have a protocol yet for taking alternatives out of the CFM. We may need to think about that at some point in the future, but we don't actually eliminate things. We simply continue to provide them. But with the ranking information provided, there is a signal that the community feels that that's an improper or inaccurate representation of the fault. Back to the first question in terms of what are the data sets that are used to constrain the fault? We don't have the degree of formality that we would have for, let's say, a nuclear, regulatory, governed process. And part of that also reflects the history of the development of the CFM. But there are two general types of data sets. There are the data sets that are extensive over the entire study area, things like the Quaternary Fault and Fault Database, particular earthquake catalogs that have been relocated. And many of the fault representations have been developed essentially using those data sets, and that process is described in a series of publications that have introduced and described the CFM. Beyond that, we do tend to rely on publications of a sort as the basis for adding faults or improving fault representations. In some of those cases, those are abstracts. In some cases, they're peer-reviewed publications. And I think our goal through this process, through these written summaries, is to give you a sense of what are the actual citations, what are the resources that were used to define that fault, so you can judge for yourself whether you think the fault representation that's documented through, let's say, a series of peer-reviewed publications should be ranked higher than one that simply has an abstract associated with it. You know, we want you to point those things out. We've tried to provide the information to help you make that judgment.
Yeah, I'd like to add that I think just after hearing these questions, I think it's reasonable for the next version of the CFM. The CFM, when you download the entire archive, comes with a metadata spreadsheet that contains things like references and average strike and average dip. Remember, those are averages because these faults are non-planar. But one of the things that we could do is we could include the rating in that, like the average rating or something like that, if it turns out we have good enough data. I mean, that's something that we could consider moving forward. So when users download the model, they can know what the rating of each fault surface was.
So again, to give maybe a specific example to help answer this, you know, I reviewed trenches that were cut across some of the faults in the Hat Creek Graben, and the dips are documented in trench logs and things like that in the reports, but these reports are not publicly available. They could be requested, I imagine. And so if I say, well, I've seen this thing and I know it dips this instead of that at the surface, if the data source is something that is not a peer-reviewed published paper, it was not allowed to be included within the update for the National Seismic Hazard Map fault data set. And so that's why I'm just wondering, since it seems like we're kind of weighing in and making judgments that might not be documented in a formal way in terms of a peer-reviewed paper, I just wanted some clarity. Should we just throw in anything we know about, even if it potentially is not accessible?
Yeah.
I would say if you know about something that we don't know about, it'd be good for us to share that information. But Alex Hayden is here, and she was one of the compilers of the National Seismic Hazard, some of it. And one of the things we're trying to move toward in CFM is following a similar level of standards to the USGS. And one of the standards that they've been dealing with is that things that they use have to be based on peer-reviewed publication.
Mm-hmm.
And so we're trying to move in that direction, but we recognize that there's a lot of work out there that's not peer-reviewed. So let us know. And that question is exactly what we're going to start dealing with in the next few years, is what is acceptable and what's not acceptable. But it'd be better for us to know about it and make a decision than not know about it.
Yeah. But again, Ray, the judgment, the ranking you provide is your own. So you should provide it based on your judgment, your knowledge, and your information, and others should do the same.
Hi, this is Alex. I'll just speak on what Ray is talking about and what Scott mentioned. We did have the rules of all the data needed to be in a peer-reviewed, publicly available publication for incorporation into the National Seismic Hazard Model fault database, but that's a clearly different application of the information and needs to be defended in a different way than a community fault model should be thought of, emphasis on the community. So I think they're sort of different threads in the construction. So I guess it's up to the organizers of the CFM what the publication requirement or criteria for inclusion or exclusion ought to be. But those are my thoughts on that.
Yeah, thanks, Alex. We also want to make sure that the community fault model is considered acceptable to be used by entities like the California Geologic Survey and the USGS. So we'll have, I'm sure we're going to have many upcoming meetings between our parties to figure this stuff out. The next session is actually over. So that's a good problem to have, I think, because it means people are asking questions. But let's have Craig ask his question. And then after that, let's move on, because there is one more Q&A session and we want to show you how to use the web tools, because we think they're going to be quite useful for you in making decisions. So Craig, if you can keep it quick, that'd be great.
Basically, I think there were just a couple of quick comments regarding what people were asking about. The original metadata for the CFM included both preferred faults and the alternatives. And so I think one of our efforts needs to be to incorporate a lot more of the alternatives in the metadata so people can see what the alternatives are. They're currently not in the metadata. And to raise issues, again, the problem that the CFM faced was largely that we often had a wealth of data at or near the surface, like a surface fault trace or some dip meter data or some geologic dip data at or near the surface. The problem is what do you do in terms of defining a 3D surface below about a kilometer or two? And a lot of the data that were available to us were often not in peer-reviewed publications, but to some extent, we used what we thought were reasonable data or observations that could estimate what the geometry was at depths below 1 or 2 kilometers. So something to keep in mind that a measurement of a dip or a dip direction even at or near the surface isn't necessarily representative of what the fault geometry is at depth, because near the surface, as Ray knows, you could have overturned faults and things like that.
Yeah, those are good points. So the last sort of tutorial session that we want to provide is to give you an idea of how to use these tools. So I am going to screen share with you. Believe you should see my screen now. Hold on, I'm trying to present and manage the participants all at once, so 1 second. Okay, so what I'm going to do is show you, I'm going to go to the evaluation tool, and the first one in the list is the north frontal thrust fault. And so you might be looking at this and you might think, okay, these pictures are very helpful, but I wish I could interact with this in 3 dimensions. And what does the seismicity look like? And all of the neighboring faults are sort of in transparent gray. Well, all of those things can be turned on and off using the web-based viewer. So click on the web viewer link in the survey. Each one should have one, and the faults should be consistently colored with the images. So it automatically loads up, again, the temporary web viewer. See how the website here is temp.scec.org. If you use the regular web viewer, the alternatives will not be in there. So this is the view of the north frontal system here, and it automatically should load up the Hoxton catalog, which is the relocated catalog of Hoxton and Shearer and other people. And the first thing you should know is that there are a lot of options here for you. Number one is you can, hold on, my little transcription thing's in the way. You can click on help, and help will pop up a box that tells you things about what the buttons do. The most important aspect of this box is 3D navigation. If you're not used to navigating in 3D, it takes some practice for sure. But how you do this in 3D is that you rotate by left clicking with your mouse and dragging. So you can see that I can rotate through the 3-dimensional field. If you want to zoom in and out, you use your mouse wheel. And if you ever get dizzy while you're looking at this screen, just look away real quick and come back, because it can be disorienting when somebody else is driving. If you want to translate, you have to hold down on the shift key on your keyboard and then normal click, left click, and drag it around. So if you want to scooch around through California, you have to hold down on shift to do that. You will see that the other faults that are not currently shown, their traces or upper tip lines are shown with pink if they are surface breaching, and in sort of like a dark orange if they are blind. So say that you look at this forever. You can also change the colors by clicking on this and apply an RGB value, or just use the color shader to change them to whatever color you want. You can even turn the legend off if you want, but I think it's pretty useful. You can make them opaque if you would like, or transparent, so you can see through them or not see through them. So that's pretty helpful. You can also change the wireframe image. So this shows you the actual native mesh of the CFM. And so you can see on these faults, for example, there's a good amount of data constraining each segment, and then the link between them has less data, which is why there are less triangles. So I think Austin was sort of asking about this earlier. And this allows you to get an idea of what the resolution of the model is. Okay. But what if you want to see the other faults in the region? Well, what you can do is you can hit close. You can't close the window because that will close the whole web tools. But if you click close down here, it will take you back to the two-dimensional web viewer. And you can see that these faults are highlighted over here in red. So we can just double click or zoom in using the button, go to that region, and I can say, hey, I want to see what all these other faults are. And you might not even know what the other faults are. So as you click on them, you can see the name pops up in the list. And if that was a mistake, you can hit the trash can to get rid of it. So I'm going to click on all of the sort of nearby faults because I want to see what those look like in 3D in relation to these other faults that are already in the model. That's good enough. Then what you can do is you say, oh, that's neat. You could load seismicity and change the background map if you wanted. But what's really cool is you can click plot 3D over here. And you probably are going to be wanting to look at the native mesh because that is based on the resolution of the data. These 500 meter and 2000 and 1000 meter, those are based on, those are regularized meshes for modelers. So they're not going to be as helpful to you. And then you'll see the whole system reloads. I'm going to turn the bounds off. Oh, they're already turned off. That's great. And now I can see the whole system in 3D. And I believe it by default, it colors the alternatives yellow, and the blue ones are the ones that are currently in the CFM. And you can change the wireframe to whatever style you want. Yeah, so that's basically the tool that I wanted to show you, is that you have this option. And if you don't like the Hoxton catalog and you want to see the Ross catalog, it's always in blue. There is not an option to change the hypocenter dot size, just due to limited IT development time. And you can turn on and off the coastlines and all kinds of stuff. You can even save images. It'll save a PNG file of your current view. And if that's too big, if you just want one for like a poster or something, you can shrink it down to a small window and save a view. Usually then you want to turn the legend off and stuff like that. So it's a pretty flexible and useful tool. And it's neat because in the past evaluations, we had to set up custom software for users to use because three-dimensional software that can view all this stuff is expensive or requires a license that requires a lot of negotiation. So that's essentially what I wanted to show you. Can you turn on depth by color on earthquakes? You cannot in the 3D view. If you go back to the map view, you can load the seismicity and color it by depth. And that is something we could add in the future, but the reason right now is because the 3D uses a VTK plugin, a visual toolkit plugin, and they all are the same object, and a color map wasn't an option for us. Should all faults with fault scarps and links over about 10 be included and added? Suzanne, included to what? Okay, so if anybody—
I'm just wondering about faults that are longer than 10 kilometers and have scarps. If we know some of those, is there a way to let you know and give you a trace and estimated subsurface geometry?
I guess you can. We probably have a lot of that information. I guess it would be a matter of if you know of information that we don't have.
Mhm.
Yeah, so like there's the cross faults in the Brawley seismic zone. You know, they're actually pretty well constrained from all those earthquakes. And in places, the Brawley seismic zone is 6, 7, even 10 kilometers wide. So do you want those faults added? Because they're, you know, the earthquakes show them so beautifully.
Yes, in the future. And what we're working on this year with the SCEC IT staff is a submission tool. So when users have new data to constrain faults or a new publication, that there'll be a web link where you can go to a form. And that way, when folks in the community have data, a lot of times they say, I have data, but I don't even know what you need. And so this form will help describe what we need, what file formats will be acceptable, and how we could use that data to improve the CFM. The Brawley seismic zone is also one that's ripe for using that objective method to constrain fault geometries.
Mhm.
Scott, do you have the TS files of the alternatives?
Yes, we do. They are not available for download through the interface because you'll notice there's this little secret triangle right over here that my little finger is pointing at.
Yeah.
That is actually where all of the alternatives are.
Oh,
And
okay.
since they're not in a formal CFM format, the naming structure isn't even identical because we want to do the evaluation first before we try to give them an official name in CFM. So if you want the T-SURFs for the alternatives, I think we could probably provide them. I'd have to talk it over with everybody, but I don't see why not.
What I was thinking, because somebody was asking about looking the faults with variable colors for the depth for the earthquakes, right?
Yeah.
So we can make the TS into a paraview format and give it to people if they wanna. And then, but of course, you will have to import the seismist in paraview, and then.
Yeah, that would assume they know how to use paraview, which is the tough part.
Okay, yeah, that's true.
And that's honestly one of the biggest challenges of the CFM is Andreas and John and Craig use GoCAD. I don't use GoCAD. I don't even have GoCAD. I use Midland Valley or Petroleum Experts Move. You use Paraview and other software. Some people use different stuff. It's very, very challenging. So apparently there's a Mira Geoscience that has free 3D viewer for GoCAD stuff. That's cool.
But you have MATLAB scripts, right? That they read the TS or the CSV.
Yeah, there's a MATLAB script that'll plot TS files. It's available for download on the Community Fault Model website.
It's just a suggestion. So that way, if somebody wants to spend more time, it could use your MATLAB script with the alternatives. And
Scott?
Yeah, here's the link to the CFM homepage in case everybody doesn't know, but you can just Google Community Fault Model.
Scott, just real quick, I just sent everybody the link to the Mira Geoscience free 3D viewer for looking at GoCAD objects. The advantage of the Mira Geoscience program, which is called Geoscience Analyst, is it allows you to import a whole suite of different data formats, including ASCII files and shape files and raster files and SegWise seismic files. It's basically a cheap version of GoCAD. And so if you have your own data sets, like you have GIS files or anything like that, that you want to compare to the CFM, you can view them with this free 3D viewer. It has limited analytical capabilities. So for example, if you wanted to measure the distance in 3D between the hypocenter of a magnitude 6 earthquake and the CFM fault surface, you can do that fairly easily in the 3D viewer. And it offers a lot of capability that the SCEC web-based viewer can't provide yet. A lot of the viewing capabilities are similar to the Move, the free Move viewer from PTEX. Unfortunately, PTEX no longer offers the free Move viewer as they did in the past. So if we want to continue to offer that as an option for people to view in 3D, the format of the CFM faults that Scott has reformatted for Move, we probably need to provide a link to our to access that PTEX free Move viewer, because
we don't provide anything.
supporting it.
We don't provide anything in the Move format anymore, just TSURF files, because Move can load those.
Yeah. Well, again, the Geoscience Analytic viewer can load the T-SURFs very quickly.
Excellent. I'm just checking the schedule. So we're finished with the web viewer tools 12:10. So we're not that far behind. And we have 15 minutes at the end for wrap up and discussion. So I don't want to stymie any questions right now.
Mhm.
I've been trying to keep up with the chat. It's a little tough. Andrew Meggs asked a great question. Can we see all of the source data in the web viewer? Oh boy, that would be awesome. But we're talking about many, many different styles of data that all come in different formats. And we have one half of one person IT development for the entire SCEC CXM. So we're just not able to do that yet. Yeah, I'm sorry, Andreas, I keep muting you because there's an echo whenever you unmute. But if you have something to speak, please unmute and say it. I don't want to feel like I'm cutting you off.
Oh, I'm sorry, I didn't know about the echo. Yeah, I mean, that's part of it, the variety of formats, but also just the amount of data and organizing and managing which is required to do that is huge. So
It's huge.
it would be a big effort. Yeah.
Sarah, if you are a GoCAD user and you would like GoCAD files, I don't know. The worst I could say is we can't do that. So if you want it and you will actually use it, feel free to send us an email and maybe we can put something together for you. I don't know.
Right.
That would be the easiest for me.
Mhm. Yeah, through the CFM viewer, you can download all of the T-surfs, of course, directly, but
Just not
we
the
have-
alternatives.
Yeah, just not the alternatives, but okay, we'll take this offline, and if we find a solution, we'll provide it to everybody who's participating today if they're interested. But we certainly could provide a set of T-surfs, the earthquake locations, maybe the Q fault traces in sort of a bare bones GoCAD project.
Just because I'm so used to doing it in GoCAD that it
Right.
would be a lot faster.
Right.
Yeah, that's the problem. Does anybody else in this group use GoCAD? I know Andreas, John, and Craig do. Does it? And Sarah, does anybody else?
So Scott, John, again, if the data sets like the earthquake hypocenters that you already have in a GoCAD format and the surface traces from Q faults in a GoCAD format and the fault surfaces in a GoCAD format, for those that don't have GoCAD, if the CFM just provides the data sets, all those data sets can be loaded into Geoscience Analyst for 3D viewing for those that don't have GoCAD.
We do. We hope people will use the web tools though. They're pretty good.
Yeah. I think the expectation for most of you is that you should be able to evaluate the 3D geometry and have knowledge of the information that was used to define or constrain those fault surfaces provided through the text description, the references cited in it, the survey tool resources essentially in the 3D viewer. So we don't want to scare those of you who might not be comfortable downloading another large tool and loading in the data. But by all means, for those of you who do this and are comfortable with this, we'll follow up and we'll try to provide some of these resources in a way that can support your analysis.
Like John said, I'll piggyback on that. The fault traces, the 3D surfaces, except the alternatives, are already available in the CFM archive. So it's really just a matter of us providing the alternatives, and the earthquake catalog is available too on Caltech's website, but we'll work on making a package for you. Yeah, web-based viewers do depend on your network speed, but once they download the data, they don't. It's all cached. So it's all, and the 3D viewer especially is actually surprisingly efficient. What's not efficient is the 2D web viewer. We had to actually write our own tool to visualize earthquakes because it was completely destroying Leaflet. It couldn't handle it. So you'd be surprised. The 3D tool is actually very efficient. And once the data is loaded, it's cached on your own machine. So it's not constantly pulling data as you rotate the model. Okay, Andrew, thank you. We really hope that the viewer is more than adequate for most people's needs, but we definitely get it. Like if you're used to using real CAD software, this is no substitute, but okay. So thanks, Alex. What we should do next is let John remind you of the important things for wrap up. I don't need a laser pointer because I'm not talking. Okay, so here we are. Description. So what exactly do you have to do? When is it due? John.
Right. So this is a one-slide discussion. We're bringing it all together. Again, we're very appreciative for your participation today, and more appreciative, of course, for all of you who are going to engage in this evaluation. So what's going to happen from this point forward? You're going to receive a Qualtrics email tonight, or depending on what time zone you're in, we'll say soon. And again, as Andreas emphasized, this is going to have a unique link to the survey tool just for you. It's unique because it's going to capture your responses. We don't want you to share it with anybody else, because if you do that, somebody could overwrite your responses and we won't be getting your evaluation, input. If, however, you recognize, now that you're engaged in this process, that there's somebody else who you know of who would be good to participate in this evaluation, maybe they have some knowledge about particular faults, maybe they're just generally, a structural geologist or a geophysicist or seismologist that works on characterizing active fault sources, you think they could contribute, by all means, suggest to us their participation. We have a simple sort of checklist process that we'll go through quickly, and we'll send them their own unique link to participate in the evaluation. We actually just got a lot of people who joined on this week when Scott sent around his reminder email. So there again does seem to be a lot of interest, and the more people we have that are qualified to participate, who engage in this process, the better the outcome is going to be. In addition, you're going to get at least one email that's a follow-up that's providing the video recording of today's session. So if you want to go back and sort of get the primer again about how to use the survey tool, you can do that. We have a number of people who couldn't participate at this time today, but are going to participate in the review. And so they're going to be watching the video. I think I'll augment this by saying we'll also maybe follow up with an email related to the packaging of some of the data sets and faults for those of you who do want to use a CAD capable tool. If you have questions about really any aspect of this process, we're all grateful that Scott is going to be willing to field those. Simply to ensure that there's a central source, that they all come into Scott, and he will work with us to sort of parse them out so that all of us on this development team can help respond to them. So you may actually email Scott and you'll get a response from me or Andreas. That's fine. We're all communicating together. But if you ensure that your inquiry goes to Scott, we'll make sure that it gets responded to promptly. The reviews are due May 19th. This year. So what that means is you have about 6 weeks to conduct this review. And as we mentioned, for some of you, it may just take a matter of a few hours and you can do it in one sitting. For others who may want to do a little research or get distracted and have to balance it with other commitments, you'll again have an opportunity to come back to the Qualtrics survey as long as you haven't hit that final submit button, and you're going to be able to evaluate additional faults, or maybe you've thought about it and you want to go back and change your ranking on a fault you've already considered. So again, this gives you time, and in that time period, again, if you have questions or concerns or comments or ideas, please feel free to reach out to us. Again, if things go really badly and you submitted and you didn't need to submit and you're locked out of your survey, that's also a reason to contact us. And as has been mentioned, we'll send you a new special link to re-engage in the survey process. So after May 19th, what we're going to do is the development team, who we've mentioned, is going to take the results and we're going to use them objectively. We're simply going to take your rankings. We're going to use those to define the preferred fault representations. Those are going to be essentially included in CFM 6.0, which will be the next release of the model. We'll be informing everybody who participated in this process of what those outcomes are. And then we're going to be presenting the resultant CFM version 6.0 at the SCEC annual meeting in September of this year. So that's basically the timeline that we're going to be working with. And we really will appreciate you being attentive to the May 19th deadline. It's really important that we get your input, what input you can provide by then. And so, if there's any further questions, I think we do have some time for those, but I just want to conclude now by, again, just reiterating our thanks to you for participating today, and again, participating in this important process. And really also to all those who've helped develop the CFM and those who've made really special efforts to develop these survey tools, these CFM fault viewers that, again, hopefully will really enable this process, aid you in this process, and hopefully improve the quality of the outcome. Okay, so turn it back over to Scott.
Okay, if you have questions, raise your hand, speak up, type it in the chat. I'm trying to keep up with the chat. We've had some really great questions in there. The biggest question, Alex raised a good one. Do you have to evaluate everything? John just touched on this. You do not have to evaluate everything. There is an option where you can leave it blank. There's blank 1, 2, 3, 4, 5. But like John said, we highly encourage you to do your best to rank as many as possible. If you read it and you say, these sound the same to me, I'm familiar with the references, then give them the same ranking. But like Andreas said earlier, that means at least you ranked it, but it will not have any impact on the final score. It's sort of like a job interview when you rank candidates. If you give everybody a 5, then you didn't really participate, because that didn't change any of the ultimate results. But we also know that everybody has finite time, so we appreciate whatever you can do. And we've tried to give everybody enough information, so even if you're not an expert, you can look at the description and the web viewer and the video and make a pretty solid, informed decision.
Yeah, and another response to comments in the chat and questions have come up. Releasing CFM 6.0 is not the end of the process. You know, we learned so much from this evaluation process about things that we can do to add additional faults, to improve fault representations, that this is really something that also inspires us to think about what comes next. And we really do take that advice and guidance to heart. And so, you know, really, particularly at that end section of the review, if you have things that you want to see put in place, please make us aware of those. We'll again focus on those as priorities, hopefully, for the next iteration of the CFM, maybe CFM 6.1 or CFM 7. We also, as Scott mentioned, are working right now on a process by which people can sign in and basically register a request to have an additional fault representation or an improved fault representation included in the model. So this is sort of a learning process for us to know what are the areas where you think those improvements should be made.
Also working on, I put it in the chat, we're working on a KML uploader feature, which hopefully by next year. So when you go to the web viewer, there'll be a button where you can push, where if you have a KML file from Google Earth that you want to see, or KMZ, you can go click and upload it and it'll pop up on the 2D map.
I don't know how to raise my hand, so I just unmuted myself. I could dump a bunch of offshore faults that aren't in the model, but they'd only be XY time and the pick points. Somebody would have to do a lot of work to get them to depth. But you know, they should be in there. I'll talk to Craig after. So yeah, I just export a bunch of faults and it's done.
Yeah. Well, the most important thing at this stage is for you to list them so we know what they are, so we can be attentive to them, and then we can follow up and figure out what's the best way to gather from you the representations. And if we need to do a depth conversion, we have means to do that. As many of you know, the CFM is only one of the community fault models that Scott has some degree of oversight over. There's also the community velocity model. So we can use different resources to try to do things like depth conversion to present at least one, hopefully self-consistent representation of fault geometry. So the most important thing at this juncture, beyond evaluating the faults that we've set out, is for you to simply list and let us know what other faults should be getting attention. And then we'll have an opportunity to follow up with you and others to collect the information and figure out how to do that best.
Okay, I'll talk to Greg.
And keep in mind too, that there's no rigorous definition of what active means in the CFM. We try to be a little bit more liberal with the definition of, we err on the side of including more things rather than less. So if people are testing things and find out that there's evidence that we have faults in there that are definitely not active, we also need to know about that. Vice versa, if there are faults that are definitely active that are not in the model, we need not just model geometries, but we need evidence for activity.
Mhm.
Because, you know, if we start putting every fault that's in California there, we're going to have 100,000 faults, you know, so we need, but again, we want to err on the side of inclusiveness rather than putting some strict, I mean, you know, the Darfield earthquake taught us some lessons about that.
Mhm.
And
Scott,
rest.
Scott,
Yeah.
the question basically I have is, as I've discussed with you and John and Andreas, obviously we've been contributing a number of new or updated fault models to the CFM for the last year and a half or so. And a lot of these fault models that are based on peer-reviewed publications or updates of pre-existing peer-reviewed faults for which I was responsible, weren't made available for review and evaluation in the CFM 5.3.2. So if we have contributions and to make to the CFM for new updated CFM faults or new additions to the CFM, how do we get them incorporated into the CFM if those contributions are being ignored?
So
Yeah.
go ahead, John.
Yeah, let me address that, certainly. So what's important to recognize about this process is that we're only focused here on looking at the faults for which there are meaningful alternative representations. So we're using this group to help us say it's representation A versus representation B that should be preferred. There are also additions to the CFM and will be additions to CFM 6.0 that are adding new faults and new structures that meet a certain set of criteria in terms of having, as you pointed out, Craig, you know, a published source that defines them, some degree of a sense of their activity. Those things will be added to the model, but they're not being evaluated here because there's no alternative. They're going to be added essentially as that representation is provided.
Well, John, the problem is that a number of the updated fault models that were provided are the faults that are being evaluated.
Right.
And they do provide updates to the faults that are being evaluated or provide alternatives to the faults that you and Andreas and Scott are evaluating with this review. It's just a little bit disconcerting that updates to faults that go back to CFM version 1.0 and which will need to be evaluated in this process, those updates that you have aren't being provided to the evaluators.
I'm sorry, part of this is just a function of finite time. I believe you provided us a lot of faults and they needed complete metadata and stuff like that. So just remember, this isn't the last version. There will be future chances for this. There are other faults that we just haven't had a chance to put in yet. You know, this is 442 faults, and just getting CFM 5.3 released was a huge effort because of many reasons. So just know it's not the last time this is ever going to happen. And we are aware that you have submitted things that aren't in there yet. So we're working on it. And we just need to know that it's going to take a little bit of time to get all of these things in and consistent to the level of all the rest of the objects. Alex, you have a question?
You've had that for over a year.
I'm looking forward to this evaluation process, and I think it's a really interesting sort of set of questions to evaluate. And I'm wondering, sort of out of sheer curiosity, how will you all evaluate our evaluations, and how is this serving as sort of a peer review process for the publication of it? I'm just sort of curious what's going to happen after the evaluation is done.
Mm-hmm.
Yes. The goal is to write a peer-reviewed publication on CFM. The next fault model that will come will be CFM 6. It will be the result of this peer evaluation, and that is what we plan to write a peer-reviewed publication on.
Mm-hmm.
How will we evaluate your evaluations? Whew, that's like a It's almost philosophical. I don't know how to answer that.
Mhm.
John, do you have any thoughts on that?
Well, I would just say, I think it's already been suggested that we will be thinking carefully about how to take the results of your evaluations and represent them as information that helps others better understand the community fault model, including its alternatives. So I think by providing a description of this process and providing the metrics that result from it, it will actually provide a useful guide to people who are diving in and looking at different alternative fault representations and trying to judge, maybe I can do a study, collect additional data that might help us better distinguish between them. So that's something that we'll want to continue to do as a community. But our first charge, of course, is to translate, your judgments and your insights into the next preferred set of faults that's in CFM 6.0.
Thank you.
Eldon asked how big the review panel is. We currently have 42 users that have agreed to be reviewers. I hope that we get 42 evaluations.
Maybe more than 42. If you, again, identify anybody who you'd like to participate in this process, we'll be pinging people and reminding people in the SCEC community about that. Again, since we do have 6 weeks to do it, there is a window here for people to join us. If you think, again, they're qualified, suggest them to us and we'll evaluate that and be back in touch if we feel that they can contribute to the process.
And please don't think my review doesn't matter. They have 42. There's no way for you to know how many of those 42 people will review the fault that you know best.
Mm-hmm.
So we need to make sure that we need to encourage everybody to review as much as they can, given their time and expertise. But again, we've really focused hard on giving the information. So even if there's a fault that you're not that familiar with, you have the information to make an evaluated, an expert decision, we think. If not, let us know. We can always learn. Alex, you already asked your question, right?
Yes, sorry.
Okay. If there are no further questions, I think it is 3:35 Eastern time. So we've already gone over by 5 minutes. I want to respect your time. As always, if you have questions, email me. I can pass it on to the rest of the team. We'll do our best. We know CFM is not perfect, but the purpose of the evaluation is to make it better. And we're going to make it better with your feedback. So we thank you very, very much. With that, I say we should break. So thank you very much for coming.
Thank you, guys.
All right.
Bye-bye.
Thanks.
Thanks, everybody.